Hello student, myself Dr. Rajiv Kumar. Today's topic is glass fractures. In this topic, you will be able to know about the physical properties of glass that make the examination of glass easy for forensic investigator, the types of glass fractures. Introduction. Most of the strength of the glass is in its surface. Glass has less tensile strength than compressive strength, so the glass bends to any force which is extended on any one of its surface. But the glass breaks due to tensile stresses that pull the surface of the glass apart and hence exceeds the elastic limit. Imperfections, flaws, or minor damage in the surface of the glass, such as scratches, bruises, or itching, which we call as glass fractures, reduce the tensile strength at those points in the surface and hence reduce its tensile strength. The study of the glass fractures gives a lot of information about the crime. For example, a fractured window glass will reveal information that can be related to the force and the direction of an impact, which is useful reconstruction of crime. When there are a lot of pieces of glass in a sample, it is advised to assemble them to know whether the glass fragments come from one or more than one object, which can reveal the brand or the pattern of the original object. A glass that has broken while committing a crime shows primarily two kinds of fractures, that is primarily of first made fracture and secondary or subsequent fractures. Primary fractures are called radial fractures, while the secondary fractures are called concentric fractures. They look like the spokes of a wheel as they radiate outward from the point of contact. Concentric fractures form a series of broken circles or across the point of contact. Radial fracture. Radial fractures are produced on the surface opposite of the one where the force had been applied. When an external force is applied on one side of a glass, then the glass sheet bends away from the force so that the tensile stresses are set up in the opposite surface of the sheet, while the compressive stresses are developed on the surface to which the force has been applied if the applied force is so strong to have exceeded the elastic limit. The glass breaks invariably from a point where a tensile stress or sufficient magnitude has developed. In a glass sheet, the primary or the initial rupture, which we call as radial fracture, tend to be star-shaped or appear like spokes of a wheel. In other words, it spreads from this point of contact as series of cracks in number of random directions as shown in the figure. For example, penetration caused in the window by a projectile or a bullet produces a pattern in which cracks radiate outwards and encircle the hole. Concentric fractures. The force continues even after radial fractures, especially when the instrument is either blunt or tapers aberrantly. There is bending moment that cause the tensile stresses to develop on the side of the glass to which the force was applied. That leads to series of cracks known as concentric fractures, which connect the adjacent radial fracture. The concentric fracture forms a series of broken circles or arcs around the point of contact, cracks seeming to make a circle around the point of impact. Motion of the projectile through the glass puts tension on the front surface of the glass, causing concentric fractures. High-speed projectile, for example, a rock, penetrates the glass. It leaves an exit hole larger than its entrance hole, help to determine the direction on impact. Types of fractures by projectiles. Bullets are a projectile force that can pass through a glass. Load side is the entrance side, unloaded side is the exit side. Load speed projectiles leave mark indicate where braking force was applied. As the bullet velocity increases, the center hole becomes smaller, cracking pattern becomes simpler, and the exit hole becomes wider than the entrance hole. When a bullet is shot at the pane of glass, the load is a projectile. The load side is known as the entrance side, and the unloaded side is known as the exit side. The same cracking occurs and the same hole formation happens. When a static load is applied, however, as the initial velocity of the projectile increases, the central hole becomes smaller. The cracking pattern becomes simpler and the central hole develops a pattern wherein the exit hole is invariably wider than the entrance hole. Examination of the edge of broken piece of glass will reveal a set of curved lines known as rib mark or stress mark. These are always nearly perpendicular to the surface at the side on which the break started, and they curve until they are nearly parallel to the surface on the opposite side. For example, the side to which the break came. In a radial crack, the rib mark will be nearly perpendicular to unloaded side and nearly parallel to loaded side. Thing will exactly reverse for the tangential cracks, which grow in the opposite way. The 3R rules help in remembering the pattern. Radial cracks give marks which make a right angle on the reverse side from where the force was applied. That is the 3R rules. The direction of lateral propagation of the cracks is always from the concave side of the rib mark towards the convex side. Thus, in radial fractures, the rib mark will be oriented with their concave side cupped toward the load point. If all of the glass pieces are present, the first thing to check for its hole made by the load of projectile, which will be wider on the exit side. As can be seen, the angle at which a bullet pierces a pane of glass can help identify the position of the shooter. If the bullet came at the actual angle from the left, glass fragment will be spread to the right, and the exit hole will be an irregular oval. If the bullet came from an acute angle from the right, glass fragment will be spread to the left, and the exit hole will be an irregular oval. The test works best when the hole is made by the high-speed projectile. In the event that the hole was made by a low-speed projectile, such as a hammer, this test will not be very meaningful. Therefore, for low-speed projectile, it is usually best of examining the rib mark. Of course, to make the examination meaningful, each edge must be determined with either a radial or tangential cracks, which is why it is so important that all pieces be collected. And interior and exterior slides of pieces must be identified, which is why it is so important that the investigator mark the proper orientation of each pieces directly on the item, as well as documentation all orientation in the notes and photos. Therefore, if a forensic scientist is examining the edge of radial fracture, whichever side shows nearly perpendicular remark will be unloaded side, that is the side way from the force that caused the break. Alternatively, if the forensic scientist is examining a tangential fracture, the side showing the nearly perpendicular remark will be the loaded side, that is the side from which the original braking force was applied. In the event that the investigator or evidence technician neglected to mark which side of the glass was inside and which side was outside, it is sometimes possible to figure out the information in the lab. Traces of window putty, for example, would indicate an exterior side, and paint traces of different colors might also be used to distinguish between the two sides. Of course, the preceding discussion assumes that the glass is not tempered. When tempered glass breaks, it produces small pieces. A fracture cannot be categorized as radial or tangential So the kind of analysis mentioned previously is not acceptable. When there are several bullet hole, analysis can determine the sequence of the impact. The first shot will cause fracture that simply run out, wherever the original strain have been sufficiently relieved in the material. The radial fracture associated with the second shot will run out when the bead of fractures from the first shot, and so on for all subsequent shots. Putting it back together again. Examiner can fit together two or more pieces of glass that were broken from the same object. Because glass is amorphous, no two glass objects will break the same. Optical properties of glass. Make side-by-side comparison using similar sized fragments. Place sample on white surface using natural lights. Use fluorescent light to determine the glass colors. Visual color analysis is very subjective. Dyes and pigments can be almost impossible to extract.